Peace be upon you, my dear students in grade 11. Today we will continue our lesson, which is polynomial functions. At the end of this video, students will be able to study the second and the third degree polynomial functions and draw their curves in an orthonormal system. Before you start, please prepare the following materials: textbook, pens, draft papers, copybook, calculator, and ruler. At the beginning, let us consider the plan for studying a polynomial function. To study the variations of f and draw c, we will use the following plan. First step, determine the domain of definition of f. Second step, determine the limits of f at the bounds of the domain. Third step, calculate the derivative function and study its sign. Fourth step, set up the table of variations of f. Fifth step, find the coordinates of some particular points. And the final step is draw c in an orthonormal system. Now we will start by our objective in this video, which is studying a polynomial function of second degree. Example. Consider the polynomial function of second degree defined by the following expression. Let C be the representative curve of f. Study the variations of f and draw C. As we said, in order to study the variations of f, we must start by the domain of definition. Do you know what is the domain of definition of f? Good. Domain f equals to minus infinity plus infinity. Why? Correct. F is a polynomial function. Second step is to determine the limits at the bounds of the domain. You know that the bounds of the domain are minus infinity and plus infinity. So, the limit of f of x as x tends to minus infinity equals to plus infinity, and limit f of x as x tends to plus infinity equals to plus infinity. The third step is to determine the derivative function and its root. F prime of x equals to 2x plus 4. F prime x equals to 0, that is, x equals to minus 2. The fourth step is set up the table of variations of f. The domain of definition equals to minus infinity plus infinity. So we will write here minus infinity plus infinity. The root of f prime of x equals to minus 2. So we write it here. The sign of f prime of x are as follows. Since f prime of x is a polynomial of degree 1 and the coefficient of x is positive. Now, since f prime x is negative, f is decreasing, and since f prime of x is positive, f is increasing. Let us look at the limits. Since limit f of x as x tends to minus infinity equals to plus infinity, here we will write plus infinity. Since limit of f of x as x tends to this bound, which is plus infinity, we will write plus infinity here. F of minus 2 equals to minus 5. As you see, the point of coordinates minus 2, minus 5 is the minimum point of the curve. Fifth step, determine some particular points of the curve. Let us start by the intersection of C with the x-axis. Thus, y equals 0. You know that y equals to f of x. So, f of x equals to 0. Therefore, x equals to minus 4.2 or x equals to 0.2 by calculator. We got the coordinates of 2 points, which are minus 4.2, 0, 0.2, 0. Intersection of C with the y-axis. Thus, x equals to 0, that is, f of 0 equals to minus 1. We got the coordinates of a new point, which are 0, minus 1. We will continue determining some particular points such as 1, 4, minus 5, 4. The final step is draw the curve. At the beginning of drawing any curve, you must start by locating the extremum points if exist. Here we have a minimum point, minus 2, minus 5. You should draw 2 arrows at any extremum point in this way. Then continue locating the other points. Join these points together. This is the curve C and called parabola. It has U shape. Application. Please stop the video, then solve this application. Now, let us continue our objective in this video, which is studying a polynomial function of third degree. Example. Consider the polynomial function of degree 3 defined by the following expression. Let C be the representative curve of f, study the variations of f, and draw C. In order to study the variations of f, as we said, first step, determine the domain of definition. Domain of definition of f equals 2 minus infinity plus infinity, since f is a polynomial function. Second step, determine the limits at the bounds. The bounds of the domain are minus infinity and plus infinity. So, limit of f of x as x tends to minus infinity equals 2 minus infinity. Limit of f of x as x tends to plus infinity equals to plus infinity. The third step, determine the derivative function and its roots. F prime of x equals to 3x squared minus 6x. F prime of x equals to 0, so x equals to 0 or x equals to 2. Fourth step, set up the table of variations of f. The domain of definition is minus infinity plus infinity, so we will write it here. The roots of f prime of x are 0 and 2, so we will write them here. The sign of f prime of x is plus minus plus, since f prime of x is a polynomial of degree 2 and the coefficient of x squared is positive. And so the sense of variations of f are as follows. The limit of f of x as x tends to minus infinity equals to minus infinity. The limit of f of x as x tends to plus infinity is plus infinity. F of 0 equals to 2, f of 2 equals to minus 2. As you see, here we have the maximum point of the curve C of coordinates 0, 2. And here we have the minimum point of C of coordinates 2 minus 2. Fifth step, determine the coordinates of some particular points. Intersection of C with the x-axis. So, y equal to 0. You know that y equals to f of x. That is, f of x equals to 0. This equation is an equation of degree 3. Use a calculator to solve this equation. First, press the mode button. As you know, we want to solve an equation. Press number 5. As we said, we want to solve an equation of degree 3. Press number 4. Here are the coefficients of this polynomial. A is the coefficient of x cubed, b is the coefficient of x squared, c is the coefficient of x, and d is the constant term. Let us write their values. A equals to 1. Press 1 equal. B equals to minus 3. Press minus 3 equal. C equals to 0. So press 0 equal. And D equals to 2. 2 equal. To see the roots of this equation, press again equal. x1 is the first root, which equals to 1 minus radical 3, which approximately equals to minus 0.7. If we press equal, we get the second root and denoted by x2, which equals to 1 plus radical 3, which approximately equals to 2.7. Again, if we press equal, what we will get? The third root, which is denoted by x3, equals to 1. If we press equal again, we get the coefficients of the polynomial. We got the coordinates of 3 points, 1, 0, minus 0.70, 2.70. Intersection of C with the y-axis. Thus, x equals to 0, that is f of 0 equals to 2. We got the coordinates of a new point, which are 0, 2. We can continue the determination of the coordinates of some particular point, which are minus 1, minus 2. The final step, draw the curve. At the beginning of drawing any curve, you must start by locating the extremum points if exist. Here we have the maximum point 0, 2 and the minimum point 2 minus 2. You should draw 2 arrows at any extremum point in this way. Continue locating the other points. Join these points together. This is the curve C. Application. Please stop the video, then solve this application.